Welcome. This is Fundamentals of Coding number 1. We are covering Code Logic 101, specifically what is an algorithm and problem-solving basics. So what is an algorithm? Simply put, an algorithm is simply a step-by-step set of instructions to complete a task or solve a problem. You have to realize that computers aren't smart, they're just extremely good at following directions. Think of it like grandma's cake recipe. Step 1, preheat oven to 350. Step 2, mix flour, sugar, eggs. Step 3, pour into pan. Step 4, bake for 30 minutes. Or look at this robot algorithm to move a block. Step 1, find block at location XY. Step 2, approach block. Step 3, activate gripper. Step 4, lift block. Step 5, move to destination. And Step 6, release gripper. It's just steps. The truth is, algorithms are everywhere. Take your GPS, it's strictly finding the fastest route. Or social media, it is deciding what posts you see. Even your microwave is running code, heating food for exactly 60 seconds. The takeaway is this: if there's a process, there's an algorithm. Now let's look at the core of logic, IPO. That stands for input to process to output. First, you have input. These are your raw materials, data, code, and energy. Then the process. This is the actual processing, applying logic and computation. Finally, the output. This is the finished product, the result, the software, or the action. Explanation. Basically, coding is taking some data, the input, applying logic to it, the process, and getting a result, the output. So how do we start? Step 1, deconstruction. You have the big problem, and you break it into Step 1, Step 2, Step 3. The concept is that the secret to coding isn't being a math genius, it's about being able to break a big, scary problem into tiny, manageable steps. And here's a pro tip. If a step is still too hard, break it down further. Next, you need to understand sequencing, the order of operations. The concept is that computers follow instructions in the exact order you provide. If you swap Step 2 and Step 1, the whole algorithm fails. Look at the difference between error and success. Success is Step 1, sock on foot, then Step 2, boot on foot. You have to get the order right. Then we have selection, adding intelligence. The logic is that selection allows an algorithm to make decisions based on conditions. For example, if it is raining, then take an umbrella, else leave it at home. See the signs? Condition equals true, then take an umbrella. Condition equals false, else leave it at home. At midpoint, we start visualizing the logic. You can use a flowchart to see the path, or pseudocode to write the logic. Read this code with me. Start. If have ramen packet is true, then we check. If have hot water is true, then add noodles to water and wait 3 minutes. Else, if you don't have water, boil water, add noodles to water and wait 3 minutes. And if, then add flavor packet. Else, if you don't have the packet at all, print need ramen packet. And if. End. Let's do an algorithmic thinking recap. 1. Algorithms are just step-by-step instructions. 2. Always start by deconstructing the problem. 3. Use IPO, input, process, output, to structure your thoughts. Master the logic, build the future. Follow us at Script Data Insights. Next, we cover basic syntax, tokens, statements, and comments. See you there.